Welcome, everybody. Thanks so much for joining us today. We're going to take a few minutes to let people join. In the meantime, please use the chat and introduce yourself. Let us know where you're joining us from today. Again, welcome to those that are joining. We'll get started in about 1 minute as folks are entering the room. Great, let's get it started. Thank you everybody for joining us today for this SEM Solution Center webinar titled Preparing the Energy Workforce for AI. Next slide, please. So it's great to see all of the different participation from people from all over the world. Thank you so much. As you enter into the room, please put your name, where you're calling in from in the chat. So before we get started, we have a few housekeeping rules for how to use Zoom. This webinar is being recorded and will be shared after the session. You're being automatically muted upon joining the webinar, and you can use chat to add your inputs and add to the Q&A to ask questions. If you have any technical issues, please message Sophie Schrader. You can adjust your audio through the audio settings or find dial-in information in your registration email. And finally, we'll be launching a survey when this event ends. Your feedback helps improve the sessions, so please fill out the survey at the end of today's webinar. For our session today, I'll provide a quick introduction to our speakers before we hear a quick overview of the SEM Solution Center. And after that, we'll get an overview of the U.S. efforts to train the next generation AI workforce. From there, we have 4 speakers who will highlight their research and programs in energy workforce and AI integration, impacts, and opportunities. And then to close our session, we'll have a brief panel with our speakers. So please feel free to add your questions to the chat, and we'll be sure to get to those at the end. So we are excited to have a mix of speakers today. We are joined by Effie Klippan from Australia's Department of Clean Energy and Ministerial, Angela Dayton from the U.S. Department of Energy's Office of Energy Jobs, Trevor Falk of North America's Building Trade Unions, or NABTU, Brinn McDowell of the National Lab for the Rockies, and Christopher Combemale from Carnegie Mellon University. And I'm your moderator for today, Dr. Kristin Wegner Guilfoyle from the National Laboratory of the Rockies. I lead workforce partnerships and analysis, and I'm really excited about the conversation today. So first, I'm pleased to hand it off to Effie Klippan to provide a short overview of SEM Solution Center. Effie is Assistant Director of Climate and Energy Division within DCCEEW with the Australian Government. Her responsibilities include supporting Australia's engagement in multilateral energy forums, and she's recently taken on the role as Australia's lead for the Solution Center. Over to you, Effie.
Thank you very much, Kristin, and good morning, good afternoon, good evening to everyone who's joining today. As Kristin said, my name's Effie and I'm with the Australian Government Department of Climate Change, Energy, the Environment and Water, or DQ for short, and I'm speaking to you today from Melbourne. For those of you who aren't familiar with the Solution Centre, Australia, together with the United States, co-leads this work stream which is one of the initiatives under the Clean Energy Ministerial, or CEM. This is an international cooperation initiative focused on energy deployment, and there are many different work streams underneath it, and this is one of those today. I'd also just like to thank the US Department of Energy's National Laboratory of the Rockies, who operates a solution centre on our behalf. The Solution Centre, for those of you who aren't aware, it was built to equip governments with the capacity to design and adopt policies and programs to deploy advanced energy technologies. We do this in 3 different ways, specifically. First is through our Ask an Expert service, and this is available to any government in need for technical or policy support. This technical assistance is available free of charge for developing countries, and all you would need to do is go to our website and apply to get the question answered. In the history of the Solution Centre, we have answered over 300 requests, which came from supporting over 90 governments. In addition to this service, we also support governments through training capacity building. So far, we've held over 400 webinars like today, which have reached more than 20,000 public and private sector stakeholders. Recordings of our past webinars are available on our website as a resource if you are interested. And speaking of resources, our resource library includes numerous reports, policy briefs, and journal articles, in addition to the webinar recordings. So there are over 1,500 resources that help support the rapid deployment of advanced energy technologies globally. I hope that you find today's webinar helpful and invite you to access the different resources we've mentioned today, like the Ask an Expert service for any energy questions you may have. And if you miss the QR code on the other slide with the contact details, we'll put them again in the chat just in case. Thank you all for joining, and back to you, Kristin. Thanks.
Great. Thank you so much, Effie. I'm now happy to introduce Angela Dayton as our next speaker. Angela is the Acting Director of the U.S. Department of Energy's Office of Energy Jobs, where she leads the department's energy workforce development strategies. She brings extensive background in workforce training and programs to her role, where she helps ensure the skilled energy workforce meets the current and future U.S. energy needs. Over to you, Angela.
Awesome. Thank you so much for this invitation to present what the DOE is doing in order to support the 21st century AI infrastructure workforce. As you all know, this is like a pivotal inflection point for us. And with the rapid evolution of AI, it's fundamentally changing and transforming the requirements of our energy workforce. The growth of AI and demand for power is leading to the build out of new power generation and infrastructure, and it's expected to impact remote and rural areas that are going to lead to opportunities across the nation. A globally competitive marketplace and workforce is at the heartbeat of America's energy priorities. And for over 60 years, the U.S. Department of Energy has been at the forefront of this mission. We cultivate a legacy of excellence and strengthening of both our national security as well as our global energy landscape. So today, I'm excited to share how this administration is unleashing American energy and establishing U.S. policies that ensure an abundant skilled workforce necessary to achieve our energy dominance. Next slide, please. As I'm sure all of you have seen, there's over 25 presidential actions that are related to energy, artificial intelligence, and workforce. This is just a sampling. And I wanted to kind of pull out some pieces of each of these to showcase the importance of workforce to the administration. For the establishing the National Energy Dominance Council, it quote, sustains and enhances America's global AI dominance to promote human flourishing, economic competitiveness, and national security. We have released an AI action plan for the nation. Under the Unleashing American Energy, we are looking to unleash America's affordable and reliable energy and natural resources and establish our position as a leader producer and processor of non-fuel minerals, which will create jobs and prosperity at home. For the removing barriers of American leadership in AI, we're expanding all forms of reliable and affordable energy production to drive down inflation and grow our economy and, quote, create good-paying jobs, reestablish American leadership in manufacturing, lead the world in artificial intelligence, and restore peace. I'll talk about the Genesis mission in just a minute, but then going into preparing Americas for high-paying skilled trade jobs of the future. This is ultimately to align the federal investments in workforce development to align our country's reindustrialization needs and equip American workers to fill the growing demand for skilled trades and other occupations. And in fact, we've actually released America's talent strategy as well. And we can't forget our youth. It's so important that we include our youth as part of our pipeline for the energy workforce. And ultimately, the Advancing Artificial Intelligence Education for American Youth is to promote AI literacy and proficiency among all of our American youth in our programs. So in addition to the DOE's investments in talent is very rich and comprehensive, we look at doctorate degrees, research awards, graduate fellowships. We have postdoctoral appointments to visiting faculty residencies at DOE national labs. The DOE provides hundreds of thousands of researchers and professionals with something unattainable in traditional academic and commercial settings, and exclusive access to world-leading expertise and the most advanced scientific facilities on the planet. So we're excited to be part of and a leader in the development of our AI infrastructure and workforce. Next slide, please. The Department of Energy is leading the Genesis mission. It's a bold initiative designed to usher in a new era of discovery. By integrating the DOE's world-leading supercomputing platforms with synergetic research from academia and industry, we're positioned to deliver breakthroughs at an unprecedented scale. And because the DOE recognizes that a skilled workforce is critical to this mission, we released an RFI back in January, which actually asked for feedback on how to mobilize the talent to support AI for science and engineering, which will be used as the deployment of the Genesis mission occurs. We, of course, are also investing in the speed to power in order to catalyze our infrastructure across the nation. Next slide, please. Specifically with my office at the Office of Energy Jobs, we do a number of different activities for the department. And of course, we're also looking at the AI infrastructure and development of the workforce. We lead the department's workforce efforts through the quantifying the magnitude of the U.S. energy workforce through the release of the U.S. Energy and Employment Report. This is a one-of-a-kind annual report that tracks energy employment at the national, state, and county level and includes data on occupations, wages, and employer benefits and perspectives. It showcases that the U.S. energy sector provides stable, high-paying employment opportunities for American workers. You can look forward to the 2026 USER coming out later this summer. And then since the USER is an annual energy employment report, I'm excited to announce that for the 2027 edition, we are updating the survey so that it will reflect AI jobs for AI roles in energy jobs. So you can look forward in the 2027 USER, which will be published next summer, to include some data related to AI workforce. The Office of Energy Jobs also engages and leads the 21st Century Energy Workforce Advisory Board for the Secretary. The board provides recommendations for the department on meeting the skilled needs of the energy sector. And we also oversee the DOE's Workforce Task Force, which allows us the opportunity to work with our program offices to ensure that the deployment of the funding is meeting the needs of industry. I'm excited to announce that Todd Mellon, the Executive Vice President of Government Relations and External Affairs by QT Data Centers, has actually been appointed to the board just recently. So as you can see, this is an important topic for our administration. We also foster and lead the engagement across the energy ecosystem from industry to interagency, labor and workforce relationships, and ensuring that we're streamlining and facilitating communications between interagencies is really important for this administration in order for us to share data as well as to avoid duplication of effort. Next slide, please. So you'll hear from the other panel members throughout this session on how AI is affecting the energy workforce. So I'm focusing more on the infrastructure and associated workforce that we're going to need to meet the unprecedented demands that we'll have on the energy sector. The growth of AI and demand for power is leading to the build out of a new power generation and infrastructure. It's expected, again, to be in these very remote and rural areas, which is a great opportunity for our nation generation, as well as for our youth. We have hosted multiple roundtable discussions through the Data Center Coalition, which is a data center industry trade group, with members of the Energy Workforce Advisory Board, as well as those that are the hyperscalers and traditional developers such as Vantage and Microsoft. We've gathered this information and the primary research to understand the needs and challenges for an AI infrastructure workforce, the aspects of site selection, and approaches to developing the workforce pathways that can then ultimately inform DOE's deployment of investments. So I'm sure many of you have seen these, but these were kind of the key takeaways that we gathered from our conversations and from our roundtables. There needs to be an understanding of the economic impact of the data centers in the local communities. It's absolutely critical. There's a general shortage of these skilled trade workers, specifically those who are electrically skilled. There's an inability to scale up training capacity due to the high cost of the training equipment and facilities. They're lacking of staffing and instructors. And one of the things that we've also looked at is what are the best practices that are occurring across the nation. We've identified successful models that have been backed by industry, such as the Northern Virginia Community College program. And then when determining site selection, developers will go where there's reliable power, and the streamlining of permitting, workforce planning often follows once the identification of power has occurred. So there needs to be really clear market signals and partnerships that are streamlining that permitting and interconnectedness for these communities. So kind of our key takeaway was the industry needs these clear market signals and partnerships to fast track the AI infrastructure and supply chain workforce. We need everything from the skilled trades to bachelor's, master's degrees that focus on dual competencies in AI and specific scientific or engineering disciplines, with a direct focus on their application in domestic energy production and advanced manufacturing. Next slide, please. And the AI infrastructure workforce spans across the entire supply chain, including manufacturing of vital components for data centers and power generation and transmission necessary to supply the data centers, and the construction and operations of data centers themselves. Energy occupations such as line workers, electricians, and robots are expected to grow faster than average occupational growth across the next decade. Next slide, please. So the energy sector powers life, business, education, healthcare, travel, safety, and national security. It's everything that makes our economy possible is enabled by our sector and those who work in it. From engineers to technicians to researchers to skilled tradespeople, individuals working in the energy field are responsible for innovation, infrastructure, and ensuring a stable and secure energy future. Their work is often performed outside of the public eye, yet its impact is felt by every American every day. We're committed to ensuring DOE's workforce initiatives are developed in a way that will support the next generation of leaders with expertise in STEM, law, economics, and policy that ultimately will converge and solve the most complex scientific and technological problems of our time. Thank you, Kristin.
Angela, thank you so much. It's so exciting to hear all of the work that you're leading, as well as your perspective on the AI workforce and infrastructure. Thank you so much for that presentation. Looking forward to diving in the Q&A in a bit. So our next speaker is Trevor Falk. Trevor is the Special Assistant to the President for the Energy Policy at the North American Building Trades Unions. Trevor works to advance policies and projects in the energy sector, which accounts for nearly 50% of all hours by NABTU's 3 million members. He brings over a decade of experience to his role with prior expertise in policy, politics, and analysis. Thank you so much for joining us today, Trevor.
Terrific. Thanks for that. Let me go ahead and share my screen here. There we are. Hopefully y'all can see that okay. As I said in the introduction there, Trevor Falk. I work for North America's Building Trades Unions. I'll give you a quick rundown of who NABTU or who the building trades are here in the States and in Canada, and then dive in a little deeper into how we are preparing the energy workforce as our members as they deploy out to go build various projects in the energy industry, how we're integrating AI into our current and existing structures, and ultimately how we're looking to use it or are currently using AI on job sites across the country. So as we dive in here, the building trades are made up of almost 3 million members across North America. That's in the United States and in Canada. These are going to be folks like your electricians, plumbers and pipe fitters, roofers, insulators, painters, large swath of folks. And they're all products of a registered apprenticeship program. That means our skilled craft are coming out of a 3 to 5 year long apprenticeship program. We currently at NAB2 run 1,900 training centers. These are brick and mortar sites across North America, to which we fund to the tune of about $2.5 billion a year. We believe that these create the most highly skilled workforce in North America, and we really like to look at ourselves as the doctors, so to speak, of construction. We're in every state, every province, deeply involved. And as was said in the introduction there, over 50% of the work we do is in the energy sector. Here's a list of our members and our unions that make up the building trades. When you think of construction, we represent it. When you think of the folks that are going to be on the ground, turning wrenches, welding pipe, whatever it might be, it is the building trades on those job sites here in North America. Diving into the AI portion of this chat here, there are really 3 key areas of focus that we look at for, again, preparation, integration, and use of AI in the energy workforce or in our membership. The first is, how can it be utilized in recruitment of folks to help meet some of that demand that Angela was speaking about there? How can it be brought and used in our training modules and our training centers across North America? Again, one of those 1,900 that we are currently running. And ultimately, how can we deploy it on job sites to the benefit of our members? First and foremost, on the recruitment side, Angela spoke very briefly there about the demands that are coming down for skilled craft, whether that be electricians, welders, what have you. We are in a state now of, we have over 300,000 apprentices currently in our apprenticeship programs across the country, and we are needing a massive uptick in folks to come into those and get out to work. As we recognize it now, we have about 315,000 members, and that number needs to be ramped up and can be ramped up to close to 1 million in our apprenticeship. But that is going to need to be done with a forward-leaning posture on recruitment, on pulling people in, on touching different communities that we have not historically pulled into the trades. So how can we use AI to help do this? AI can be used, one, to create a more targeted outreach to whether it be young folks, disadvantaged communities, different populations, and an increased effectiveness in developing messaging to reach those communities, as well as identifying pathways for greater market exposure as we look to recruitment. It's also just at a base level, as I'm sure many of you all use on a day-to-day level, helping maximize our staff engagement. As we have 3 million members across this country, we have a very nimble staff network of folks looking to grow that number, pull people in, run our training centers, everything else. So this is just our generative AI that helps us move through those processes quicker. Additionally, using some predictive models as a method for recognizing more advantageous ways for hiring and recruitment, and tracking the retention and success ultimately of those recruits that we pull in. There are many efforts that have historically gone on in the recruitment of trades workers that have been effectively an effort to throw a large amount of money at a very small population with a very limited success rate at the end of it. We need to get smarter about the methodologies that we are using to reach out to folks. We need to get smarter about tracking them through our training centers, through our curriculum, and ultimately as they deploy out to job sites. AI has a terrific upside in recognizing those trends, identifying them, and then ultimately learning from them. Secondly, the big pot for us as we look for preparation, integration, and use of AI in the building trades is in our training. That is really our bread and butter. This is where we thrive. We've been training folks for over a century in North America. We take a great deal of pride in it. We are currently at the introductions phase, I would say, to many of our training directors across North America. We really currently right now have an instructor-focused exposure to AI tools, making sure those folks know the benefits that can be had there, how it can be used to expedite certain processes that they're going through, and how it can be used to enhance the creation of different teaching materials, whether that's curriculum, homework, tests, what have you, really allowing them to recognize the benefits and expedite their time that is already very condensed as they work to train a rapidly demanding, rapidly in-demand industry of workers. Additionally, our folks internally have been using AI to help and benefit in the translation of materials to promote diversity and increase membership. Again, referencing back to some of that recruitment effort there, translating our curriculum into Spanish, French, Mandarin, whatever it might be, to meet people where they are at, understanding that a skilled trade is not beholden to one language, as it were. Additionally, going forward from there, as we mentioned in the recruitment portion, increasing our ability to recognize retention trends, who is able to progress forward, and as well using AI to identify different sticking points throughout the curriculum and throughout the 3 to 5 year apprenticeship program that our folks are going through. Using AI to identify on a test, when did it take longer, right? When were people getting tripped up? When were they having challenges? And then taking a little more time to identify those issues, address them, increase training, maybe alter language for it, whatever it might be to get the greatest amount of success. And lastly there, maximizing staff capabilities. As I mentioned, with 3 million members, I would say we are a rather nimble crew here. And then the third pot is really where the rubber meets the road, and that's deploying AI on job sites. In the construction industry, there are really 2 key components that every job wants to have. And by job, I mean project here. It is being on time and on budget. And we recognize AI, and I believe our developer partners recognize AI too, as a method to cut project costs and deliver projects on time as well. We're seeing more and more project managers, that is at our general contractor partners or developer partners, that are using AI to help optimize schedules. That is the timeline for construction. We're seeing more and more folks utilize AI to recognize workforce needs and workforce demand as things like the very infrastructure needed for the development of AI, that is data centers, continue to be built out at a rapid pace across this country. Next, we're also using AI internally as a way to analyze risk and historical data to prevent injuries on job sites. The construction industry is one of the most deadly and dangerous industries, particularly here in North America and across the globe. And it is our goal every day that our workforce comes to a job and leaves it the same way it came, that is happy and healthy. Historical data and analyzing risk can be as simple as seeing what time of year are more injuries happening. Why is that taking place? Recognizing on a job site when and where injuries are happening, and then trying to do our best to mitigate that specific spot, even if it's something as mundane as trip hazards, right? Or even as dangerous as fall risks. We are also seeing quite a bit of our industry partners utilizing tools to streamline modeling and testing. And why is that important for the building trades? Ultimately, if our developer partners, technology owners are able to streamline their modeling and their testing, they're able to bring projects to bear, and that is to deployment earlier and quicker and safer. And for us, that means jobs. That translates into paychecks and food on the table for our workforce. This all sounds terrific. I will want to hedge here a little bit and say that there are challenges as we look to the deployment and preparation, integration, and use of AI across the construction industry. First and foremost, we are a very safety-focused culture. And recognizing that with that, we want to make sure all the AI tools that are being used, whether it's to analyze risk, develop new curriculum, or what have you, are done in a safe fashion and that they are proofed. There is a degree of industry hesitancy, as you can see with any industry in the adoption of new technologies that is present here in the construction industry as well. There are some concerns over capital costs. It is an outlay at the initial, right, with a recognition that there will be massive benefits likely on the back end. And then the last key component here is, I will say this, there's a limited historical data within the construction industry. That is not to say that there is none. We would always love more, but ultimately that data will help build out the knowledge of various AI tools that can really benefit the construction industry and our members here at the Building Trades. Finally, what's the outlook for us here? Ultimately, our workforce and the energy construction industry writ large can greatly benefit from this as a methodology to meet demand in just sheer workforce numbers, and as a deployment to job sites, keeping us safe, well-trained, and ultimately more productive at the end of the day. We are seeing an increased exposure to AI tools. That's what the Building Trades are currently working on now by getting it in our training centers, advancing that knowledge with the trainers, so to speak. And we are going to recognize here in the coming days a rapid expansion within the energy construction industry going forward. I appreciate your time. I appreciate y'all listening to me here. There's a massive upside for us in the construction industry if we do things safely, intelligently, and with a forward-leaning posture. Thank you.
Trevor, thank you so much. It's impressive to see the full breadth of your work and the opportunities you see for AI to contribute. Thank you so much.
Thanks, Kristin. We stay busy over here. Thank you.
Looking forward to diving more into the discussion too. So our next speaker is Brinn McDowell. Brinn is a workforce analysis researcher at the National Laboratory of the Rockies. She specializes in assessing energy sector workforce readiness, developing cross-technology evaluation methods, and analyzing the impacts of robotics and AI on industry-specific skills and competencies. Brinn, thank you so much for joining us today.
Hi, thank you so much for inviting me to present on one of our AI and workforce analysis capabilities. So we can go to the next slide, but AI, oh yes, here are some of the contents that we'll go over. We can go to the next slide as well. And then the next one. Awesome. AI is already reshaping the human workforce, creating both opportunities for skill development and challenges in adapting to new technologies across all job levels. Nearly 2/3 of occupations will be influenced by AI, with the degree of impact varying by sector and task. Currently, 33% of college graduates use AI in their professional work. Nearly half of the US workers engage with AI tools monthly, although 20 to 30% have expressed anxiety over adoption. Next slide. In the energy sector specifically, there's a reinforcing loop driving AI adoption. On one side, companies are increasingly using AI to deliver secure, reliable, and affordable energy. This includes robotics and AI-enabled manufacturing for improved operational efficiency, machine learning techniques that optimize energy usage and reduce waste, and real-world simulations to model complex energy systems and enhance decision-making. On the other side, energy is essential to power the expanding use of AI itself. This means AI is now influencing strategic siting of energy-intensive data centers, planning transmission capacity to support AI-driven loads, and addressing supply chain capacity to support AI-driven critical energy infrastructure. Together, AI and energy systems are becoming more intertwined, each enabling the other's growth and capabilities. Next slide. The key point here isn't that AI isn't just a technology shift, it's reshaping workforce demand in both numbers and skills across the entire energy system. So the question we're really asking is, do we have the right talent pipeline, particularly in areas with high AI usage? And do workers have the skills to actually use AI and tools in a real-world workflow? Next slide. So what we've noticed is that while researchers are expanding tremendously on the work in this topic, Energy sector leaders currently lack information and a structured way to anticipate how emerging REI technology will reshape specific tasks, occupations, and regional labor markets before large-scale deployment occurs. Research has primarily happened in general industry sectors or in an occupation level, which ignores the task level nuance of how AI interacts with human workers on a day-to-day operation. Next slide. Before jumping into one of our methodologies we developed, I wanted to give a brief overview of some of our workforce capabilities and where the REI, or robotics and AI workforce impact capability, falls into it. So next slide, please. We typically describe NLR's workforce capabilities into these 4 buckets, which is tool and resource development, so education and training maps, occupational maps and databases, career maps, and then it goes to workforce analysis, which is all of our national workforce assessments down to local workforce assessments, and then workforce pathways, such as some of our collegiate competitions, and then industry engagement, so workforce networks, accelerators, working groups, conferences, prizes, etc. The REI workforce impact, if you click on the next slide, falls within our workforce analysis work. However, it's meant to inform both program creation as well as tool and resource development. So if you go to the next slide, we can kind of jump into this methodology. The methodology that I'm going to be sharing today is going to be based on a case study that we did for hydropower operations and maintenance. However, it's important to note that this methodology can be used across technology types. I also want to give the author acknowledgement to Haijing, Megan, myself, Byron, Jennifer Daw, and Jeremy Stefik, who really drove and led a lot of the creation of this methodology and the creation of the journal article that is currently under review. So if you go to the next slide. So public conversation often focuses on job loss, but in high demand industries, the reality is much more complex than that. And as mentioned before, often research only looks at occupations across industries in general, but doesn't necessarily provide the nuance needed to make data-informed training curriculum. This nuance allows us to understand that automation doesn't just replace roles, it fills critical labor gaps, creates entirely new job types, and really just works on augmenting and transforming skill sets needed within the workforce. So really the unknowns are, how will this transition unfold? Which occupations will be most affected? What skills will the future workforce require? So our project goals for this were kind of twofold. One, to perform a technology landscape of hydropower operations and maintenance, to establish a foundation for robotics and AI integration at the task level, and 2, quantify REI integration in hydropower operations and maintenance occupations and assess impacts on key industry workforce tasks. Next slide. To drive this methodology, we used 2 conceptual frameworks really to guide this analysis. The first one is a coactive design framework, which I'm showing on this slide, and the second is an REI, or robotics and AI taxonomy. The coactive design framework describes how humans and technologies interact at different levels of automation. By mapping a task that a technology can perform along the spectrum, we can really quantify the exposure each occupation has to REI integration. We also can determine the automation level a task is likely to face based on technology capabilities. So a low extreme, or that automation level of 0, is when a human is considered the primary performer of the task and robotics and AI is not applicable to the task. A high automation extreme is when AI is the primary performer and it operates entirely without human intervention. Next slide. The hydropower REI taxonomy framework was created to help classify hydropower-specific robots and AI technology into 4 main categories, which is artificial intelligence, digital twins, Internet of Things, and robotics. Each category has relevant subgroupings, and really this enables us to create a coding system where we can align the technology capabilities with the tasks performed in specific occupations, which allows for that direct comparison and impact assessment. Next slide, please. So here is the methodological flow chart. On the top part is this occupation profile, which really identifies and defines the set of occupations within a target industry that we're working with, in this case, hydropower operations and maintenance. And it links each of those occupations to a list of tasks that, for our case, are being transformed and being modified to be hydropower specific. The bottom part is the technology profile, and this is done through a literature review of journal articles, industry reports, and technical manuals. And we use like ChatGPT, so we use AI in addition to expert manual verification to draw out the tasks and the capabilities that those technologies can perform in their hydropower application. And then it is linked to a coding system as described in the hydropower REI taxonomy. We then applied the coactive design framework, or that level of automation that I described a few slides ago, for each of the technology tasks pairing. And really that helps to show the human and AI collaboration spectrum between the occupations and the occupation profile and the technology profile tasks. We then match those two sides together, and once we have that matched, then we can do then we can identify whether and how a task is impacted by REI technology and at what automation level the task is likely to be performed in the future. This kind of integrated approach really allows us to quantitatively measure the exposure of hydropower O&M occupations to emerging REI technologies and the potential shift in human technology roles. Next slide. This is just kind of a quick overview of some of the examples of the REI applications that we identified in hydropower. So one example would be with equipment fault diagnosis and predictive maintenance. And then we have some of the technologies that were identified to be able to perform that type of a task. So on the next slide, here are the results of the jobs that we kind of ranked. And this is the top 10 impacted jobs based off of our REI methodology. Hydropower technician is on average the most impacted, with an average automation score for each of its tasks to be 4.6, which means that it's REI led but shared with human supervision and intervention. The rest of the colors along this kind of spectrum indicate the percent of tasks that fall within each of these REI exposure levels. And again, this is for the top 10 most impacted jobs, but we did it across all of the jobs within hydropower operations and maintenance. Next slide. The other benefit of this methodology is that it allows for comparison with national data sets. So this is a US national data set called ONET, and ONET has its own automation index, but again, it's across the industry, so it's not industry specific. You can see that the size of the bubble is based off of the projected growth of employment between 2023 and 2030 for that occupation. The color is the major SOC, or the occupation code grouping. And so kind of combining occupations with high REI exposure with positive employment growth are really those highest priority targets for upskilling. And you can kind of interpret this as they're facing transformation, not displacement. Some conclusions that we can gain from this type of analysis, you can see on the next slide. And some of the ones I wanted to point out here are that nearly half of all hydropower O&M tasks were found to be unaffected by sector-specific REI integration, and most affected tasks fall within augmentation or shared control configurations within that coactive design framework. The second point is that REI integration is most prevalent in analytical, monitoring, and optimization activities, whereas hands-on, field-based, and context-specific work remained predominantly human-led. And ultimately, this task-level framework provides a foundation for workforce planning, training, and system design, enabling a co-evolution of human and REI roles in hydropower, O&M, and beyond. Next slide. We do want to mark some limitations to this methodology, which is one, it's only covering REI technologies that are already documented within hydropower O&M. So it doesn't necessarily capture the ability of transferable applications from other technologies and other sectors that may not have been applied to hydropower at this moment. The other part of this is that there's gaps in available REI data, which could lead to an underestimated exposure score. Again, on the similar vein, literature may be outdated or overly optimistic. It may not truly reflect what industry is actually putting in terms of technology and what they're using. And so one of our next steps is actually to talk with industry members and then adjust the scores based off of their usage of the technology itself, as opposed to the theoretical usage that's within literature review and technology manuals. And finally, there's no task weighting. So within an occupation, we aren't weighting if they use that task more frequently or if the duration is treated differently between the different occupations. And so for the sake of this methodology, it's just treated equally across the board. Next slide. And that's it from me. So thank you.
Brinn, thank you so much. Thanks for sharing both lab capabilities as well as your work on the robotics and AI research. I always appreciate how you developed a novel methodology that both uses AI as well as analyzes robotics and AI for occupations. And thanks for sharing some of your future research goals too. Super exciting. Also excited to dive into the conversation in a little bit. Thanks. So I'm now excited to welcome our final speaker, Dr. Christophe Combemale. He's an assistant research professor at Carnegie Mellon University, where his research focuses on the implications of technology choices and process design for skill demand, on workforce supply chain levers to meet industry skill demand needs. He's interested in regional and national labor supply and how it may constrain economic productivity and innovation, as well as solutions to enhance outcomes for workers and firms. So Christophe, over to you.
Thank you very much. Let me share screen here, and there we are. This talk brings together a number of different projects, both across my role at Carnegie Mellon and also consulting work that I've done with DOE in the past and with other federal government clients. The main theme that I'm interested in exploring today is whether the demands associated with AI infrastructure build-out and maintenance might also be a source of labor market resilience at a time of deep uncertainty about the demand for worker skills. So to set the agenda a little bit, if we look back at recent industrial transitions, and I'm going to focus on a couple of them today, but you may think of large labor market dislocations caused by trade and globalization, historical patterns of automation. What we found is that many workers tend to have limited exit options. Labor markets recover, individuals often don't. And some of the AI exposure evidence suggests that this pattern might repeat, which is to say that the labor market as a whole may be resilient, but individuals who are disrupted or displaced may have significant challenges in finding wage-sustaining transitions. Infrastructure for AI may offer resilient jobs that are associated with AI demand, but which are themselves in operating environments that are difficult to automate through AI. AI may augment workers in those contexts, but is relatively unlikely to replace them. And there's going to be enough compensating demand that efficiency gains will not reduce total employment. And so then I'd like to close after I show a couple of examples of this with some thoughts about what it might take to build a transition pipeline in order to support movement from vulnerable occupations into occupations that are actually aligned with increasing demand in a high AI build-out scenario. So a bit of table setting here. As I've just said, not all displaced occupations have equal exit opportunities. What I'm showing you here is an example of work published in the Proceedings of the National Academy of Sciences with Gillian Miles and Valerie Karplus looking at industrial decarbonization of iron and steel. So in this case, decarbonization achieved an important energy goal, but also was associated with a reduction in labor hours for the same level of capacity. Many of the facilities that we studied did not have a compensating increase in demand, and so there was a reduction in labor. What was important, though, is that not all occupations were equally vulnerable to this disruption. If you look at the figure on the upper left, the industrial machinery and mechanics, what you're looking at is what we perhaps somewhat dramatically called a survival curve in the labor market. We're characterizing the number of occupations, kind of external opportunities, for which a worker in a region may be qualified based off of their level of similarity to that occupation. So as you move along that horizontal axis, you're saying, basically, I'm going to require that you be more and more similar to the occupation that I'm considering you for before I say you can make that transition. And so in other words, we're saying that the further along this horizontal axis we go, there are fewer jobs, but it may be easier for an individual to transition. And so the shape of these curves is really important because it suggests that for the industrial machinery mechanics, there might have been a few jobs for which they were very, very close based off of their occupational skills. And this is actually also based off of ONET, so I appreciated the call out of ONET in the previous presentation. But at the same time, as you relax that similarity requirement and kind of increase your tolerance for matches, the number of jobs available to these workers increases rapidly. And so the takeaway here is that these individuals may be able, with a relatively small amount of retraining, to open up lots of options for themselves. On the other hand, if you look at the lower right-hand corner, the laborers and material movers had a long way to go on this skill similarity axis before they had a significant number of job opportunities for which they might be competitive. So the takeaway here is that some occupations facing the same technological disruption may actually have a demand for much more training or much more of a managed transition in order to relocate themselves within the labor market. So the second piece of motivation is to think about wages. That first piece of analysis was wage agnostic, right? We started by just asking how many workers might be disrupted, what occupational skills do they possess, and what might be their exit options. When we looked at possible transitions for automotive workers in an EV transition scenario, what we found was that the high wage premia associated with, in this case, automotive sector workers, actually were very limiting in terms of wage sustaining exit options. There were jobs these individuals could do, they had lots of skills, but there were very few jobs for which they were highly prepared that were going to pay them the same as their current industry. And so when we think about transition planning and when we think about aligning a surge in labor demand with a potential decline in demand or a transformation in demand in other sectors, we also need to be thinking about that wage dimension. And so the figure that you're seeing here on the horizontal axis is just showing you the annual pay of different exit options for which disrupted workers might be highly prepared. On the vertical axis is the number of those jobs which may be available. And each of these three panels shows a different degree of similarity tolerance. So as we go from a 0.7 to a 0.8 to a 0.9, we're again sort of restricting that similarity requirement so that we are looking at the jobs that workers could easily take now or with very minimal retraining. What we find as we move further and further to the right is that the distribution of occupations that are potential destinations for disrupted workers, in this case, in the automotive sector, not only there are very few of those jobs, comparatively speaking, but that if you look at the black dots in these figures, those are the distribution of wages for incumbent automotive workers. So the third dot, if you can see my cursor on the right-hand panel, is showing you the median wage of an automotive assembly worker in 2023. We could have updated this analysis today and probably shown a similar story. But the key takeaway is that that individual, in order to make a wage-sustaining transition, not only has few exit options, but may actually need to be competing with workers who are in those green and light cyan bars. And those bars indicate workers who are at the top of their own occupational distribution. So it's not just that I have to make a transition, it's that I have to transition to the top of the wages that people earn in other occupations that are similar to my own. And so this again suggests that there may be a lack of market transition potential for disrupted workers. So I've given you some examples from a couple of historical cases, recent history, but what does this mean for AI? All discussions of AI exposure start with the disclaimer that exposure does not mean automation, but it is probably a pretty good indicator of where transformation may happen, and transformation can include automation. So we need to be humble, I think, about the deep technical uncertainty around what AI can do, as well as, I would say, the deep uncertainty about the economics of AI adoption. What is technically feasible is not necessarily economical. And so these are really scenarios or possibility spaces, not concrete projections. But if you take across the literature the sort of cottage industry of AI exposure scores that have been produced, and there's a half a dozen very nice papers that deal with this exposure question, and they all are pretty correlated with each other, right? There is a pretty strong consensus, actually, that has emerged across these exposure scores about the types of occupations that are, quote, most exposed to AI. And these are often occupations which are very legible digitally. And so if you look at the right-hand figure, the takeaway from this is that if I am highly exposed on the horizontal axis, my exit options based off of historical labor market transitions, kind of where people who do my sort of work go when they leave my occupation, are also highly exposed. There's a really strong correlation there. That's maybe not surprising. I'm likely to move into jobs that are similar to mine, and if my job is exposed, similar jobs probably are as well. But it's extremely salient because it suggests that there may be a large-scale fragility issue in the labor market for workers who are disrupted. If I'm disrupted, my exit options are likely to be disrupted for the same reason. And so I may have to go much further in skill space, which, as you saw before, for certain occupations is really hard, in order to find a wage-sustaining transition to a new job. The left-hand figure suggests something that I think is also really important when we think about the creation of occupations or increasing demand for occupations that are not likely to be automated. And that is that an occupation's exposure score is also highly correlated with the exposure score of workers who come into that occupation. So we're just flipping the math here, but the correlation is persistent. And so what this suggests, if you look in the lower right quadrant, is that workers who are not exposed have very few historical transitions into their jobs from workers who are exposed. And so that implies that if an occupation is disrupted, non-disrupted occupations may be very hard to enter. And so there may be a need for a managed transition. And so this is why thinking about apprenticeship programs and training pipelines is really important when we think about labor market resilience in the face of a disruption scenario, which, while uncertain, could be extremely disruptive if it were to occur. So I've given you a lot of preamble about why we need to think about the cost of disruption for individual workers, why we need to think about labor market resilience, and why less disrupted jobs may need a managed kind of entry path. What does this mean for the build out of supporting infrastructure for AI that is relevant to energy? Well, I'm going to focus in this example, just because I'm limited on time, on the build out of power line installation and maintenance and repair. Maintenance and field deployment work may be very AI driven. If I'm going to build out lots of data centers, if I'm going to build out a new, modern, capable energy infrastructure, I'm going to need to build out a lot of transmission capability as well, potentially, just as one example. But building off of some past work with my colleagues Alice and Kristin, we argue that past patterns of automation have been driven by a combination of output frequency and step length or step complexity. That work that was relatively simple but could be done fast tended not to get automated. It was technically feasible to automate, but it wasn't worth automating. It wasn't economical to automate. And I'm happy to talk about that reasoning in the Q&A if there's interest. But what's interesting about Gen AI is that it widens this cone of automation pattern. Because it's able to be very flexible. Generative AI can very rapidly be retasked. It's able to also deal with much higher input uncertainty than kind of classical analytical forms of automation. But AI needs digital legibility, right? It needs to be able to capture the data about a process or a system. And it needs those processes to be pretty separable still. You need to be able to break things down into steps. If you've ever worked with an AI tool with sort of a deep reasoning function, and you see the way that it structures its solution, it needs to break things into small pieces. So adoption may be impaired by contexts with high variability, high interdependency of tasks. If I get one thing wrong, I fail the whole process. Low tolerance for failure, and low environmental control. That sounds an awful lot like field deployment and maintenance. New problems, different types of problems. Nothing breaks in quite the same way every time. And if you're building out literally in an open physical environment, you can't control all the parameters that you might want to control for AI deployment. So the energy rollout to support data centers might be driven by AI, but it might also be challenging to automate. And so this suggests that we might be looking at a very large demand for low exposure occupations, and potentially an opportunity for job growth. So given this potential, the first question we should ask ourselves is, are the opportunities matched to the geography of exposure? Are the labor markets that have the highest AI exposure in terms of their occupational composition also where we see data centers? And with apologies to my international colleagues on the call, we're using some great data from the Pacific Northwest National Lab looking at data center projections for the United States, but this could absolutely be extended internationally. And so what you're seeing here, the little white boxes are current data centers. The blue dots are projected data centers under one of the projections that's been developed by PMNL. But what you'll see is that they correlate, not perfectly, but pretty strongly with the darker colored states, which are the states whose labor markets are maybe the most exposed and could, in a disruption scenario, have possibly the greatest labor market fragility. And so states with high labor market exposure also appear to have clusters of current and projected data centers, which implies they might have a clustering of demand and for build out and maintenance. So the next question is, since this build out is happening, and since that build out seems to be overlapping with potential disruption, is that talent supply matched to the demand? The US Bureau of Labor Statistics estimates just under 11,000 new power line installation and repair jobs per year. I think that there are a variety of technical scenarios that add some uncertainty to that. It could be much greater. But to take their analysis just for the moment, if you look at high similarity jobs, meaning jobs that have similar tasks, similar associated skills, similar associated abilities, they could meet demand, but they're likely to see demand surges themselves. So if you look on this figure here, on the horizontal axis, we have the number of labor market transitions that occur from jobs that have a certain level of readiness to become power line installation and repair workers. So we're asking how many people are moving in the labor market at any given time who are not dropping out of the labor market. They're just moving somewhere else. This is the pipeline you might be trying to capture. And if we look at high similarity, we see that nationally across the US, there might actually be 250,000 people every year who are moving occupations who might be within a they have a lot of the essential skills you might be looking for. But of course, those skills are likely to be in demand, not just for power line installation and repair jobs, but for an entire portfolio of demand across the AI and energy transition. And so we can't take for granted that those jobs those potential workers are going to be available, because they're likely to be the source of pretty fierce demand competition, which is a great thing for those workers. So then the next question is, can we relax our requirements through training or through assistive technology to enable low similarity workers to make that transition? And as you can see, what that might enable is an order of magnitude increase in the number of transitioning workers who are currently making at or below the median wage of power line installers and repairers. So there may be a talent crunch, but this should be, I think, a source of optimism to suggest that we actually have potentially, with a sufficiently well-built training pipeline, the ability to relax that requirement for similarity and very potentially access a very substantial labor supply. So in the interest of time, I just want to make a couple more quick remarks. One is that the regional impacts from enabling less similar transitions might be very regionally dependent. So if you look on the left-hand figure, relaxing from high similarity to low similarity, and I'm happy to talk about the quantitative definition of high versus low similarity either in the Q&A or offline, we see maybe a 9x increase in that potential pipeline. If we look at Pennsylvania, my home state, it's a 15x increase. And so what this suggests is that there's probably benefit to everyone of increasing this tolerance on similarity and building out the kinds of great programs that we've heard about from other speakers today, but that some regions may really benefit from it. There may be an outsized benefit to certain regions. And so this might need to be something that is thought of in a state-by-state, not just a national or a supranational way. Very briefly, the capability gaps that might exist for some of these workers making transitions. There are, of course, a variety of extremely occupation-specific skills. There are certifications that are required to become a power line installer that are candidly not well measured in the ONET database that we use in the United States. I think generally this is a challenge internationally for measurement of worker skills. We're pretty good at measuring generic things, but often there are really specific skills that are not always as well captured in some of the administrative data. And so that's an area for improvement. But the takeaway here is that most of the important skills, knowledge, abilities, work activities for these maintenance and installation roles are a mix of problem orientation and physical cognitive characteristics. And some of these physical characteristics might be hard to train. It's possible to train a person on a particular physical procedure, but it can be difficult to train them into the level of basic physical dexterity that is required to perform a particular operation. And so this may be an area where there's scope not only for training, but for worker augmentation. So I want to close with a few open considerations. The first is something that comes up a lot in my work, is that the number of jobs is not equal to the number of job years. We talk about a surge in labor demand, but I think we want to be sensitive to the demand that's associated with construction and the demand associated with maintenance. Maintenance demand is likely to be much, much lower than construction demand. And so as we think about a potential surge, we should be excited about that opportunity, but we also really want to be thoughtful about transition options for those workers that we can credibly message to job seekers, right? Saying this is a perhaps temporary surge, but you're going to gain skills that open up a wide variety of other opportunities for you in the future. The second, we've talked a lot about wage-sustaining transitions, and something that I think is really important to keep in mind is the difference between absolute wages and relative wages. It's very attractive to talk about creating good jobs with high pay, and that's something that of course, we want to encourage. But I think we should be equally interested in how much of an improvement in wages we're offering to the median transitioner. And so when we think about job design, we might actually want to prioritize not just the absolute level of pay, but the accessibility of the job. And we might be prepared to accept that a job is less well paying, but can be accessible to a wider base of people with lower wage alternatives, and that might actually be a greater net improvement in their life. Lastly, I think it's important to think about both the half-life of skill demand, sort of how fast does the skill frontier move relative to how fast we can train. And I think that's a major concern that we encounter in our conversations with workers and in our research, that people are skeptical that the investment they make in training is going to pay off over a long enough horizon to make back the time and potentially money that they've put into it. And so there's a question here about signaling lead time on how far in advance I can be confident that the demand will be there, as well as how confident I can be about the duration of the demand. And so that's, in some sense, the personal level mirror of the kind of macro question about number of jobs versus duration of jobs. And then the last, I think worth keeping in mind, really in any context when we think about managing a disruption, is that the closest skill matches may not be the most vulnerable workers. And this goes back to that figure that I showed you about possible correlation of exposure. If we want to be thinking about a whole of society labor market transition, we may need to look beyond the most immediately convenient transitions if we want to really pick up people who may otherwise be disrupted and may be left out of transition and of prosperity. Let me stop there. Thanks.
Christophe, thank you so much. That was such an engaging presentation. Really appreciate the rich data and insights, and especially the conversation on wages and energy infrastructure, skill frontier. That was a lot of interesting things for me to think about too. So I'm excited to dive into the broader conversation. Thanks for this presentation. A huge thanks to all of our speakers today. We've heard lots of really interesting topics and themes around AI workforce strategy, infrastructure, occupational trends and skills. I have a couple guiding questions. I encourage people to drop questions into the chat too. So with that, we can proceed to our discussion. So again, panelists, please respond, jump in to the conversation. I have a couple guiding questions for some of you, but would really love to have a conversation. I think we have enough time to dive deep into some of these different topics. So the first question, and I'll first point to Angela and Trevor about credentialing. Would love to hear, how can credentialing frameworks evolve with AI-related skills? We heard Christophe mention the ONAP measurement skills. Brinn shared different occupational methodologies. We heard about retraining and worker augmentation. How are you thinking about different credentialing frameworks?
Trevor, I'm happy to jump in here from the DOE's perspective. But when we're looking at the credentialing frameworks that are needed, we truly go out to industry. And what does industry need for a skilled workforce? And ultimately, what are the industry recognized credentials that are being produced? I would say our role at DOE is to understand those industry needs, the labor market supply and demand, and then ultimately ensure that the deployment of the available funding is relevant to that demand need, and incorporating the requirement of the utilization of those industry recognized credentials. We at the department have a program called the Energy Skilled Recognition Program, that we are able to actually take these industry recognized credentials, evaluate them for effectiveness, and then ultimately provide like an energy skilled kind of I guess, name to it, just like our the energy kind of appliances that we utilize. And so, we at the department are really also looking at apprenticeship programs are absolutely critical, making sure that we have the earn and learn. In Secretary Wright's letter to the Energy Workforce Advisory Board, he committed to scaling these pathways for apprenticeship and earn and learn. And so part of our job at the Office of Energy Jobs is actually to be consultants for the program offices to ensure that the right occupations are being trained and the right credentials are being used.
Perfect. Yeah, and I'll just hop in here and say from a purely construction standpoint, I think that there's a great deal of interest in this and the structures moving forward. I think Angela hit the nail on the head with engaging industry and understanding what they need. I can say from our training centers and our apprenticeships across the country have a long history of adapting to new technologies. My boss always likes to remind us that at one point in time, there was a buggy whip making union here in the States, and that has gone the way of the dodo, right? So we have to lean forward and understand what's coming at us and new technologies and new methodologies for doing things. And particularly, we recognize the fact that industry is going to know what's best for the deployment of their technologies. But at the end of the day, we have to listen to our folks on the ground to get that feedback from what they're doing and how they're seeing it play out to day to fine tune those structures and those credentials and what have you. We have a long history of adapting very quickly when we need to. I make reference to the offshore wind industry here in the United States. We deployed a curriculum and a number of different credentials across the entirety of the Northeast in a matter of months to our training centers in order to deploy and get ready to build those facilities. We did the same with the nuclear industry, post our folks building out the Manhattan Project here in the States, and then, massive amount of nuclear build out, all to say that we have a history of meeting those demands, but it comes through a great partnership with industry folks, people like Christophe and others that have a high degree of the knowledge behind the scenes as to deployment and intelligence of how to build these things out properly. It's a space that we take a lot of pride in being able to adapt. I think the other thing I like to lay out as we speak about credentials is a lot of different developers and technology owners believe that their technology is special, which it is. But at the end of the day, the basic concepts behind electricity or fluid or whatever it might be, or welding, does not change. So making sure that we're doing our best to integrate new technologies while finding a way to tie it in the most simplistic and effective manner to the concepts that we were already teaching our apprentices across North America.
That's great. Thanks so much. Especially appreciate that perspective around being flexible and adaptive and how we've done that before. Those are great examples from the Manhattan Project to offshore wind. A question for everybody, and then again, folks keep putting into chat. I see a couple and I'm excited to get to the chat questions, but I have one more for all the panelists. So how does AI impact vary across regions, industries, firm sizes, from small to big companies? We've heard a bit. Christophe mentioned different projections across the United States. Would love to dive more into that. We've also heard about it in construction, but would love to hear more about the variations. Again, regional, industry, firm size.
So I can speak to that a little, yeah, if you don't mind. I can speak a little bit to that on 3 dimensions. One, I think it's worth keeping in mind that the AI technical frontier is way ahead of the diffusion of that technology into the rest of the economy. If you look at adoption, it's very focused on tech firms and financial companies, and we're starting to see it. We're starting to see signals of adoption in other sectors, but it's very immature. It's usually not penetrated very much into the organizational structure, or it's being led by individual workers. And actually, I think that's something that's really worth considering is what's different about AI as a technology from maybe past technologies is that because it's essentially service-based in terms of its diffusion, it's relatively straightforward for workers to lead on the tech adoption. It doesn't necessarily have to be a top-down organizational choice, as long as the organization is friendly to that adoption decision. And so I think that means that, one, diffusion is hard to measure, so it's possible that we're missing big parts of that adoption picture. I think you see some results of that with some of the data coming out from Anthropic about AI adoption. But that, I would say, has its own problem, which is that we don't really have a great measure of personal versus business use. We've got lots of people using and querying Anthropic, And we have almost no idea, actually, when you really dig into the data, whether they're actually doing it at work or whether they're doing it for themselves. And so this lack of information about worker level adoption or firm level adoption, again, means that I think we probably have a tendency to overstate how fast these things diffuse, but we also have a pretty fuzzy measure of that. I would say, just briefly, where we're seeing the most potential for adoption is again in environments that are very digitally legible, right? If everything that you're doing is already in an ERP, in some kind of digital system, it's quite easy to integrate that into an AI model and to empower AI utilization. Um, Much of the US industrial base is not that way. I mean, I do a lot of work with the Department of War, in which there are facilities that are still using paper records. Those are not strong candidates for AI diffusion and adoption. And so I think we should expect there to be a really long tail, actually, of very slow adoption, particularly in the physical environments across the economy.
Yeah. Oh, I was just going to jump in really quickly too. So for part of our methodology, we did a literature review across energy industries to try and figure out kind of what some of the major drivers were of AI adoption. Granted, it was under the lens of robotics and AI adoption. So some of this technology adoption is a little bit different depending on how you're defining, I guess, the scope of what AI is. And so one thing that I'll notice, some of the primary drivers really had to do with safety of the worker or it had to do with predictive maintenance. And so, for example, like digital twins helps to reduce costs for a lot of these firms or a lot of these energy facilities because they're able to predict when they're actually going to have to send people out to go look at, let's say, an offshore wind turbine, or have to go and use a robot to look at, let's say, a hydropower dam to see if some of this like maintenance is needed. And so I would say the two main drivers right now, at least from literature that we were seeing, are safety and also predictive maintenance.
And if I could add here too, I think there's a key point as we look to the folks that would build out these facilities, that long tail that was referenced there is going to take some time to play out, but it's also as it affects the construction industry, we have an aging population as far as, electricians, welders, whatever it might be, roofers are considered. And that generation that has exposure to AI is just now starting to pass through our apprenticeship programs and really enter the industry with any sort of weight that I think will start to show itself in use and in deployment and what have you, particularly in an industry that is somewhat insulated as far as the physical nature of the work itself is somewhat insulated from the larger, more quickly deployable AI tools.
Great, thank you so much. I have another question, and this is including part of the chat question. So thanks for putting that in. I encourage folks to continue adding questions into chat. So how is AI reshaping specific tasks within occupations? We've heard about some of it, but I'd be also curious about the range of jobs within an industry too. So all the way from apprenticeship, also to management. There's different skills. We've heard about different methodologies, LLMs, Gen AI, obviously across the spectrum and the different professional levels, people are going to be using different skills. What kinds of things do people need to know, or what are you seeing in the field in terms of upskilling, reskilling, different types of things that people are learning?
I can take that one quickly. So two observations. One, when we think about tasks, it's also really important to think about the structure of tasks. So how separable tasks are from each other is going to be really important in whether or not a job is successfully augmented using AI. So there's a lot of information that you could give an AI model, but which it then cannot interpret or action, and so you have to sort of continue to operate and kind of handhold it. And so particularly in executive roles, there's a lot of contextual knowledge, a lot of sort of requirements gathering and process management that has actually been quite difficult to automate, even though subsets of that are actually relatively trivial for AI to perform. And so there's a sense in which I think that task structure piece has been really important to measure. But the other is there's been a really interesting question in the research literature about whether it is more or less skill intensive to evaluate the outcome of a task or to do the task. And I think this varies actually depending on the job environment you're in. If lots of physical tasks are relatively easy to evaluate, very hard to do, right? I can say, even as a relatively untrained person, with a basic amount of training, that screw has been turned fully in. But I might need to, if it's at a particular angle or in some sense, there's some complexity to it. It might be physically more difficult to perform than to evaluate. And so the question I think at hand is, are we going to use AI to evaluate tasks or to perform tasks? And I think one of the major questions for workers there is, do we want to be evaluated by AI? Or do we want to be the ones evaluating AI outputs? And I think there's actually pretty good evidence, particularly in physical environments, that AI is serving more of an evaluative kind of tracking function than it is a performative function. Whereas in digital environments, it's more often the other way around.
Would anyone else like to comment on that one? Yeah, Trevor.
I'll just throw out there that I think as far as a evaluative methodology for physical infrastructure, we're beginning to see different developer partners and people across the energy industry that are recognizing patterns for where a given facility might be wearing down, or where a proper evaluation or inspection from a actual physical, trained electrician or what have you would be warranted to go in and fix something, recognizing those patterns, using AI as a way to best use their time, not in the sense of an aggressive time management, but in the sense of you have a limited number of workers that can go do X task. Where is the best use of their efforts? And that's paying dividends not only for our workforce that are able to be active and be productive, but it's also showing itself, I truly believe, over time here, will continue to show itself as a benefit to the grid writ large, and a bringing on of more capacity as we try to power all the great things that are happening here in the States and in Canada.
Yeah, I really appreciate that perspective. It made me think about keeping human in the loop too, to make sure that we're having those reflective thoughts and making sure that we're optimizing appropriately. Thanks. Brinn, we have a question for you in the chat. Can you share a little bit more about your methodology?
Yeah, I can definitely share more about the methodology. I'm not sure if whoever wants to put it in the chat wants to expand on what portion of the methodology itself that I should be expanding upon, but I think maybe just starting from the occupation profile matching. So that's typically done by attaching it to a standardized occupation classification code, and then it's adjusting the tasks that are associated with that code to be industry specific. And so that's kind of the top level that I was showing. The bottom level is probably more of the methodology that you're interested in, which is where we're taking the literature review. We are pulling out the different technology capabilities and then all of it, classifying it based off of the technology type, as well as its like industry specific application. So we get into like very detailed levels of this AI umbrella and what the definitions are. We don't just say like AI, we're going to be saying a deep neural network or whatever the like specificity is. And we attach that to a specific code based off of like different groupings. So it gets more and more specified. And then that code is attached to tasks that we use. We use ChatGPT to pull out the tasks that are associated with the technology, and then assign each of those tasks another specific code and tie it to the automation level based off of the coactive design framework. And that's given context within the literature review as well as technology manuals. That code and then that automation level is where we're going to be using industry kind of specific data to then change how much the technology is actually integrated within the industry itself. Because to Christophe's point, it's like not always accurate within literature how much the actual technology is used in practice. And so then we're taking that, adjusting it, and it matches up the tasks of the occupation to the capabilities of the technology, assigns it based off of the automation level and the exposure score, and then it gives that ranking. So you see each task has a different automation level. And that's where that chart was with the top 10 most impacted in the colors. And then it's showing how the primary performer and the secondary performer interact. So how the human and the technology interact together based off of task. I don't know if that answered the methodology question, but hopefully
I
that
love
helps.
that. I would just say, as watching this methodology evolve over time, it's really fun to hear how, one, you're researching AI and robotics, but also you're developing a new methodology. So the first time I heard that you're using ChatGPT to actually look at the data, I think that's where I started to really think about that. So it's helpful just to hear how you might be using that, both as for analyzing the data and then also just like what are the prompts that you're using too.
Yeah, and one quick follow-up is that we're starting to look into creating our own large language model so that we're able to actually pull the data in real time and keep it up to date based off of industry, either postings or again, technology manuals, web scraping, and then being able to do this quicker across all technologies so that you can start seeing the transferability between technology capabilities and other industry needs and workflows as well. But all of that is very much in the mix, but it would be cool to include AI in our work more.
Great. Well, thanks. We have time for one quick rapid lightning session. I'd be curious to hear from each of the panelists, just especially after we heard from each of you with your presentations and the discussion and the participants in this today too. Just one last nugget or takeaway or insight or challenge that you'd like to present to people. What should we be thinking about as we close out the session? Anyone like to go first? Brinn, over to you. You're the largest on my screen right now. One takeaway. What are you most excited about? What should we be thinking about?
Oh, I would say I'm most excited about seeing how much research is now going into the space between workforce and technology capabilities and just how mature it is becoming. I would say using AI as a tool and having that human interaction, technology interaction kind of blend is something that I'm really excited about seeing being used more in the future. And yeah, Christophe's analysis also made me really excited because I thought that your research was incredible. So I think those are my two things.
Great. Thanks, Brinn. Christophe, over to you since you just mentioned you.
Sure. Well, actually, one of the questions I think we discussed in the sort of pre-panel meeting that I think is really an interesting takeaway for me is that the technology here is moving so fast. As I said, that frontier is moving really quickly, and something that I think is actually salient from Brinn's work and that is really exciting is that historically, when we wanted to track how labor markets moved, we had to rely on really long latency retrospective data, and that was okay when the markets moved slowly. But now AI, particularly large language models, enable us to process the semantic content of things like job postings and resumes in a way that was just not possible, certainly not at scale, even 5 years ago. And so I'm actually relatively optimistic, and this is a lot of work I'm doing with partners at DOL and NSF, in our ability to keep pace with that technological change by using those methods to track what's happening in the labor market, and kind of getting ahead of those low latency methods. I think that the challenge is that the way that, at least in the US, we track data on the labor market is still really high latency. I mean, ONET, to be clear, it's a backbone of a lot of the analysis we've done. Those occupations get updated at 10% per year, right? It's a 10-year update cycle. It is obviously way, way too slow for the pace of labor market transformation. So it's a challenge, but I think it's a solvable challenge.
Thanks, Christophe. Trevor, over to you.
Yeah, I think there's a lot to be excited about here. Much in the same way that I communicate to folks that I believe we have all the tools necessary currently to meet energy demand, rapidly rising energy demand across the country. I think what's amazing about the AI coming to play, particularly in the construction industry, is that we were met with a challenge that so often we're rarely given solutions for, and that is a massive uptick in demand for workforce needs, particularly in the United States here. And by the grace, we were given the solution to meeting that demand, which is utilizing AI for methods for pulling more people in, exposing them to the great things that a career in the trades has to offer, utilizing AI tools themselves to help folks be more productive, live better lives, maintaining their standing in the middle class, what have you. It's a terrific opportunity leaning forward, and I think something that will help bring about a lot of good if done properly, safely, and responsibly.
Great. Thank you so much. Angela.
So I would say that we're most excited about ensuring that there's policies and strategies in place in order to have the affordable and abundant power that's going to be needed for the AI and our other economic priorities. I mean, ultimately, through the Ratepayer Protection Pledge that was recently signed, we want to make sure that the data centers have the power, but we also want to ensure that the consumers' electricity costs are still low. The other really, I think, exciting AI usage that I did not speak about that DOE has produced is the permit AI. So one of our, I would say, strong opportunities that we have is to accelerate permitting so that we can advance the build out of our energy infrastructure that's going to be needed. So I'll put the link in the chat, but definitely excited about this space as well. And just ensuring that the deployment through the program offices and the technology and the research that's being conducted at DOE is also including workforce development and workforce training that is up to date and incorporates the necessary technologies for the individuals that would be trained through the federal funds.
Great. Thank you so much. I'm so glad you had an opportunity to share that too. Thanks.
Yeah.
Well, thank you, everybody. A huge thank to our panelists. This was such a lively conversation. Really appreciated the presentations and discussion. Thank you, everybody, for joining. Please join us for the next SEM Solution Center webinar, Planning for AI Era Infrastructure. So registration information will be sent out soon. Please keep an eye out for that. And with that, I'm happy to conclude today's session. Thank you so much for joining us, and we'll see you at the next one. Thank you, everybody.